everyone. Let's look at this initial value problem. It's from section 4.10. Not this exact example, but this is a topic from section 4.10. Okay, so let's look at this example. What does it say? Suppose that f prime of x is 3 times the square root of x minus 2 raised to x. And f of 4 is 8. You need to find the function f of x, and you need to find f of 9. So what do? We're given the derivative, and we want to find the function. Okay, so what is f of x? F of x is the antiderivative, is an antiderivative of f prime of x and satisfies f of 4 is 8. Okay, that's what we have to work with. Okay, so first let's write down what would an antiderivative of f prime be. It will just be the integral of f prime. All right, so let's say f of x equals 3 square root x minus 2 to the x dx. Okay, so 3 times integral x to the 1/2 dx minus integral 2 to the x dx, okay? So I split it up and took constants out. Okay, now what is the integral of x to the 1/2? Integral of x raised to any number alpha. As long as alpha is not equal to -1, will be alpha, x raised to alpha plus 1 over alpha plus 1 plus a constant. Okay? It's just something to remember. If alpha is not -1, then this is what the integral of x raised to alpha is. And you can easily check, differentiate this. Alpha plus 1 in the denominator is a constant. X raised to alpha plus 1, when you differentiate that, alpha plus 1 comes down, and it'll be x raised to alpha plus 1 minus 1. So it'll be x raised to alpha. The alpha plus 1's cancel, and that will be x raised to alpha. Okay? So the integral of x to the 1/2 will be x raised to 3/2 divided by 3/2. So when you put 3/2 in the denominator, you could put it as 2/3 like this. Okay? And minus, what is the integral of a to the x? Well, what do you differentiate to get a to the x? Well, you do differentiate a to the x, but when you differentiate a to the x, you get a times a log x. So to get rid of that, log a, to get rid of that, we multiply it by 1 over log a. So the integral of a to the x is a to the x over log a. And you can check again, differentiate this, and you will get a to the x, okay? Okay, so this will be 2 to the x over log 2. And then let's add a c. It's some constant. You know that no matter what that constant, if there's a constant you add to this, it'll still satisfy that f prime is this function given up here. But we're going to put a constant here and figure out what our constant needs to be to satisfy f of 4 is 8. Okay? So far, that's what we have. Okay? So you have f of x is this. Now f of 4 needs to be 8. Let's write it like this. Okay, but let's plug in 4 over here. Oh, by the way, I forgot. We should cancel out these 3's. Okay, let's plug in 4 over here. It'll be 2 times 4 raised to 3/2 minus 2 raised to 4 over log 2 plus c. Okay, and that needs to be 8. 4 raised to 3/2. What is that? You do this as 4 raised to 1/2 raised to 3. 2 to the 4th is 4 times 4. That's 16 over log 2 plus c. 4 to the 1/2 is 2. 2 cubed is 8. 8 times 2 is 16. So it's 16 minus 16 over log 2 plus c, and that needs to be 8. Okay, that's easy now. We can just solve, and we get that. Bring these guys over there, and we get that c is equal to 16 over log 2 minus 8. Okay, you can subtract 16 from both sides and add 16 over log 2 to both sides. So you have that f of x is 2x raised to 3/2 minus 2 to the x over log 2 plus 16 over log 2 minus 8. Okay? And this function over here, when you differentiate it, you will get this. And if you plug in 4, you will get 8. So it satisfies both of these. So you found the f of x. All right? All right. And now, next part, you're asked to find f of 9. So easy, just plug in 9 into this. Okay, what is 9 raised to 3/2? First, you raise 9 to the 1/2. You get 3. 3 cubed is 27 times 2. It's 54. What is 2 to the 9th? I don't know if you guys played the 1024 or 2056 game. But anyway, those are powers of 10, of course. So this is 512 over log 2 plus 16. Oops. Over log 2 minus 8. Just fix it all up and you get 46 minus 496 over log 2. And that is f of 9. Okay. And that's it. So this is an initial value problem. This is considered to be your initial value. You're given the derivative of a function. You're given a point that the function passes through, and you have to find the function. Okay? Oftentimes you'll have examples where you're given the acceleration. So let's look at another example. We have, suppose that the acceleration of a body is given by t squared minus 1 over root t plus 5. Okay? So suppose that's the acceleration of a body. And you are told that the velocity at time 0 is 8. And you're told that the position at time 0 is 10. V of t is the velocity at time t, and s of t is the position at time t. Okay, so what you need to do is find the velocity and acceleration functions. Velocity and position functions. Okay, so first step, we're given the acceleration. What do you know about the acceleration? That is v prime. So you know a of t, which is v prime t, is t squared minus 1 over root t plus 5. Okay, let's rewrite this like this with powers because it's easier to deal with when you want to find the antiderivative. So what will v of t be? It will be the antiderivative. So the integral of a of t or v prime of t, whatever you want to call it, that's what you have. And you know the integral of a sum is the sum of the integrals, so I'm not going to rewrite it separately. But you know t squared, we know integral of t to the alpha will be t to the alpha plus 1 over alpha plus 1 plus c. But we're not even going to have separate c's. We're just going to put it all together as one c. So this is t cubed over 3. Oh, this is a negative 1/2, sorry. What is t to the negative 1/2? Now, integral of that, you have your alpha be negative 1/2. So negative 1/2 plus 1/2 plus 1 over negative 1/2 plus 1 plus what's the integral of 5? So what do you differentiate to get 5? 5t, and then you put 1c for all of them together. Okay, so just rewrite this better. T cubed over 3 minus square root t over 1/2. So 2 square root t plus 5t plus c. All right, so that's your velocity function. Okay, well, not quite, because there's this c, and c can't just be any constant. Why? Because you know the velocity at time 0 needs to be 8. So that is 0 cubed over 3 minus 2 square root 0 plus 5 times 0 plus c. So in this case, you know, we could have had to plug in 1 or something. Okay, so in this case, c is 8, and you have the function v of t is t cubed over 3 minus 2 square root t plus 5t plus 8. Okay, so that's the velocity function. Next, you need to find the position. Well, what do you know? The velocity is the derivative of the position, so the position will be the integral of the velocity. Okay? All right, integrate term by term, because when you have a sum or difference of functions you want to integrate, you can do them term by term and then add or subtract as per the sign in front of them. So t cubed, 1/3 is a constant that sits there. Integral of t cubed is t to the 4th over 4. Minus 2 is a constant that sits there. So let me put this. That turns into this. T to the 1/2 will be t to the 3/2 divided by 3/2. So you're multiplying by 2/3. 5 is a constant that sits there. Integral of t, this is t to the 1, so it'll be t to the 1 plus 1, 2 divided by 2. Integral of constant 8 is just 8t, and then you'll add a constant of integration. Okay, so that is your s of t, but c can't just be anything, because you have to plug in 0, and you must get 10, because you're told that s of 0 is 10. So let's just write it down. Sorry, actually, let's write s of t in a better fashion first. It's t to the 4th over 12 minus 4/3 t to the 3/2 plus 5/2 t squared plus 8t plus c, and we will find the c. S of 0 we know needs to be 10, so that's 0 over 12 minus 4/3 times 0 plus 5/2 times 0 plus 8 times 0 plus c. All these turn out to be 0. They need not have turned out to be 0. Might be some number, and that's fine. Then you just solve for c. In this case, it was easy. It was just 0 plus c. So c is just 10. So you have that the position s of t will be t to the 4th over 12 minus 4/3 t to the 3/2 plus 5/2 t squared plus 8t plus 10. And that is your position function. And you had that this was your velocity function. Okay? So I hope this made sense. All we needed to do was integrate to find velocity first, plug in the initial value, find the actual function without the unknown, then integrate that to find the acceleration, the position function with the unknown c, plug in the initial value, and solve for that unknown constant. Okay? I hope this was easy. And please let me know if you have any questions. All right, bye.